Hi guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of LeetCode. So let's get started with today's question. Today's question is sort of an interesting question, but I believe uh, that you will enjoy the same. So let's get started. We have to return the matrix in spiral order. We are given an m cross n matrix, and we have to return the order of elements in a spiral order in a 1D vector, in a 1D array. So let's get started with today's question. So I've drawn a matrix over here, and now I let's just jot down the desired output that we are expecting from this result. That is uh, 1, 2, 3, 6, 9, 8, 7, 4, and 5. I guess this is what the answer is. Yeah, so this is the correct output that we are expecting. So let's discuss the intuition for the same. So I think the solution which I'll be discussing right now is the most easiest way and also the most efficient way to solve this question. So let's get started. So whenever we are trying to move in a spiral order, what we are observing, we are moving, first of all, we are moving from left to right, and then we are moving from up to down. Then again, we are moving from right to left, then down to up, and then again left to right, and the cycle goes so on and so forth. And whenever I get my destination, I just complete my cycle. This is what the cyclic order of this spiral matrix actually means. But there is one thing that we need to take care of is while we are moving in a spiral order in a matrix, we have to make sure that whenever we move in a spiral order, we have only four directions to move. Either we can move up, either we can move down, either we can move left, or either we can move right. So in all, while moving in a spiral matrix, we have four directions, right? So we have four directions. So we need to keep a track of these directions while moving while moving in a matrix. So let's discuss the uh, discuss about these directions. So we in all I've already mentioned in the green that there are four directions: left, right, up, and down. So our pointers. So we'll be moving in this matrix in using these directions only. But whenever so suppose let's start. So let's just start moving in the matrix right now before just getting it to any other point. So suppose in the first iteration, what I will in the first direction, what I am expecting is I have to move from left to right. Okay. So what my direction number one actually indicates. So my direction one actually indicates my movement from left to right. So after moving from left to right, we are moving from up to down. This is what the this is what is expected in the spiral. So my direction two, which I assume it to be from up to down. Okay. So now let's make out our direction number three, which is from right to left, and the direction number four states our movement from down to up. Okay. So while moving in all of these directions, we need to take a note of one of these things, that whenever I traverse from left to right, so there is one thing whenever I reach my rightmost point, this is the last point that I will reach in direction number one. So actually, so what is the effective area of traversal that is left after covering this whole portion in the first traversal? So the effective area left out is these two these two rows, right? Which is basically a what I can say, it's a 2 cross 3 matrix that is left. So whenever we are moving from left to right, so what is happening is, so after completing one of the traversals, what we are actually assuming is that we have actually covered one of the directions. Like one direction is already, like one part of the matrix is already covered. So we have to simultaneously update the other directions while keeping track of these movements as well. So since I've so let me assume one more thing, that I start my left from 0th index, up from 0th index, right from n minus 1th index, and down from, uh, since it is a m cross n matrix, okay, it would be n minus 1 only, and down from m minus 1th index. Okay, so this is what the just uh, let me assume, yeah, it is n minus 1 and this is m minus 1 only because I remember from the question. So after completing this whole traversal from my left to right, so what is happening is that whenever I just shift down, so the effective area of traversal remains 2 cross 3 matrix only. So do you think that there is a need to shift my up pointer a bit down? The answer is yes. So whenever we are moving in a direction one, so after completing this traversal, we have to actually increment our up pointer by one. This is what the general assumption is, because in the next iteration, what is happening is we are moving from up to down, and already we have covered one of the elements of the above row. So I don't think that there is any need to restart our traversal from this element till this element. So I think we have already covered while traversing the array. So we can simply increment our up pointer before jumping to the other direction. So while moving from up to down, so again this case is happening. So we have covered this portion of our array. So effectively this portion has already been covered. So what is the amount of traverse? So what is the effective amount of array that is left for traversal again? So it is a 2 cross 2 area, right? So while moving in a spiral matrix, what we are observing is our area of our span, like the way in which we are traversing is, we are actually reducing the size of the subarray in which we have to make our traversals, right? So that's what the intuition is. So while moving from up to down, do you so what is the next direction in which we will be after completing this traversal? So assume that I've already completed this traversal. What would be the next traversal in which I have to actually start? The right to left traversal. But do you think that again restarting my journey from this very element 9 is a wise decision? The answer is no. So after completing this traversal, after completing a traversal in direction number 2, we have to actually decrement our right by 1, because in this case we have already covered the first element of direction number 3. So see what is happening over here is we are actually getting overlapped with the first element of the next direction. So that's why we have to basically decrement or increment the direction count accordingly. So the same case goes here with the direction number 3. So assuming that I've already covered this right to left portion. So what do you think? What is the effective area of span in this matrix which is left out? It is a 1 cross 2 matrix which is left out. So in order to traverse this 1 cross 2 matrix, do you think is it really wise to restart my journey from 7 again and then move upwards? The answer is no. So, after covering this third direction, we will actually decrement our down direction by 1, because in because what is happening is we are tending to go from down to up. So, and we have already covered the first element of our next traversal, so I don't think there is a need to cover this element again. So we can simply decrement our down by 1, and we can move further. So, coming up to the next direction, which which is the part of a traversal, do you think we need to go up? The answer is no, because we have already uh, taken a step, because our already the up pointer is present over here. Okay, so we will only move one step further in this case. So after completing this traversal, basically this 4 and 7 as the traversal, 7 and 4 in a traversal, we are moving, we are moving, we are restarting our journey again from left to right. So, in order to restart this journey, so what will happen is we will restart this journey. So obviously, as a common sense, we have to restart our journey from this point only, from where the 4 is left. But do you think is it really good to again overlap with this first element of the next reversal? The answer is no. So we will simply increment our left pointer over here, because in this case we are starting again with the direction number 1. So these are all the assumptions that I am just taking down while moving up in this spiral matrix. And whenever there happens to be a condition that my up re- up is greater than down, or my left is greater than right. So in this case, it means that I have already traversed my matrix. That's what the assumption is. So, or we can say this in some other way as well, like mm, just give me a sec. I think my computer got hanged up. Okay, so cool enough. So let me just redraw all these lines again. So we can even assume this condition to be like this as well, that we will be actually traversing it up till the condition that whenever my up is less than equal to down, because this condition happened down again over here when I was trying to move from down to up, and also whenever my left is less than equal to right. And a for sure thing that I wanted to say is that both of these conditions will happen out to be at the same point whenever we reach the central portion, which is the eliminating point of this traversal. So that's so this condition. Uh, Sorry, I mistakenly said that this condition will happen at the end. So it means that whenever these conditions satisfy, we will keep on moving in our matrix in the spiral way. That's what the intuition is. Because what I'm trying to say over here is that whenever my up is less than equal to down, so why I'm saying that up is less than equal to down, because I'm starting my up from 0 and my down has started from the m minus 1th index. And whenever my up supersedes the down value, so it means that we have already covered that element in the spiral before. So this condition, so up greater than down is an impossible event. So this will not happen. and whenever my left supersedes the right, so what does it mean? That I have already covered that element before in the spiral matrix, right? So this condition of left greater than right will actually, which is an impossible event, and whenever it will occur, so it means it actually states that we have already covered that element in the spiral. So this, so both of these conditions will not occur, so we have to prevent them. So we can simply use this condition, that whenever my up is less than equal to down and left is less than equal to right, because in this case that the assumption is that we are actually covering all the unique elements in the spiral. That's what the intuition is. So now let's just write up a pseudocode for the same. So whenever I have direction number 1, I'll be moving from left to right, and after completing this left to right traversal, uh, what will happen is I have already covered one of the first elements of my next traversal, right? So after completing this traversal, I will simply increment that element, right? I will not cover the copy of the same, okay? So whenever my direction is 2, I will simply move from up to down, because this is what is the expected behavior of spiral is. And after moving from up to down, what will happen is I have already covered the first element of my next traversal, right? So I will simply move one step for backward in this case, because in the next direction what is happening is we are moving from right to left, okay? So now whenever I am in my direction number 3, I'll simply move from right to left, and after making this traversal, what will happen is I will simply just decrement my down direction. I'll simply move this down direction upwards in the matrix. And whenever I am in my direction number 4, I will simply move from down to up. And after completing this whole traversal, I will simply increment my left, because I am covering the first element of the next traversal in my previous iteration only. And now in order to keep a track of these directions, what I will simply do, I will simply update my directions with direction plus 1 percentage 4, because we have only 4 directions in this case, so that's why I am taking a modulus with 4. And even if we talk about direction 1 2 3 4, we can assume it to be 0 1 2 and 3 as well, because in this case this formula of direction holds true. So that's what the uh, pseudocode for this problem lies, and let's jump to the code for the same. So this is the all about the code. So whenever I'm moving in my direction number 0, I'm taking a traversal from left to right, pushing all those elements in my answer matrix, moving as I've already covered the next element of my the first element of my next iteration. So I'm simply incrementing or decrementing the values of the same accordingly, and I'm simply keeping a track of my directions using this formula, direction plus 1 percentage 4. And now let's just run this code. I think it seems to be a super easy code, and this is being asked in many of the interviews as well, as per the YouTube and the LeetCode discussions that I've gone through. So now let's just submit it. Okay, so uh, not a big deal. So it beats 100% of the runtime, and also it takes up the less memory. So let's go through the time complexity of the same. So the time complexity is m cross n because we are actually traversing through each and element of the matrix, and the space complexity is big of 1 because we are not actually storing any of the outputs in some extra space. We are rather storing the outputs in the answer matrix that is required. So that's all from my side. Thank you guys. Keep on watching my videos. And if you're new to the channel, please do hit the like and subscribe button. And if you feel that there is any feedback, uh, or there are some doubts, please do mention it in the comment section. I'm ready, and I'm ready to take up those doubts as well. So thank you guys. Keep watching. Share my channel with your friends as well. Thanks a lot.